When you already know the answer to a question, the solution is easy to see. The problem becomes a problem when you don't see. And what you don't see is me. I'm standing behind the problem. It's this center beam, pillar, or column that goes up to the ceiling. You see, it all depends upon your point of view. Whether it's a sporting event like a basketball game, or maybe even the senior assembly, this guy may just get in your way. And there's one over there as well. So the problem is how to remove these beams. And better still, why are they here? Well, we asked Port Huron High School Principal Ron Willeen to tell us about these beams.
Well, the building was built in 1955, so we have pretty close to 50 years of ducking the beams at Port Huron High. And I have some personal experiences that I can share with you as a student, because I'm a graduate from Port Huron High School. Setting up in the stands, looking around those beams and looking at assemblies or the principal at that time. And then I had two daughters that went through this school as well. And as a parent sitting in the stands, and again, once again, dodging the beams and looking around during the honors assembly. And now as principal, as I'm on the floor and I'm looking up at the student body, again, kind of dodging those beams and looking around. So they've been there for a long time. When I finally realized that they're going to be removing the beams, it was just, I tell you, we were very excited because over my years, there's been always a, hey, we're going to get those beams out of the way, and now it's going to happen. And that reality, I mean, everybody's going to benefit. We're excited because now we're going to be able to see no matter where you sit in those stands.
But still, why were the columns here in the first place? Well, in order to get to the bottom of that question, we went right to the top, to the Port Huron Area School District Superintendent Bill Kimball, who's been here for over 34 years.
Well, that's a little history question, and I did do some research on that over the years. And when the new Port Huron High School was built back in the early 50s and the planning was being done, they wanted to do some things at the school that they ultimately weren't able to do because they didn't have the money. They wanted to have a swimming pool, and they actually planned for it. And they also wanted to have the gym without the columns. And as the high school was developing and money was tight, they actually had to do some cutting back. So one way to save money was to eliminate the swimming pool. Another way to save money was to put the columns in. And I understand that saved them about $50,000, which at that time would have been a tremendous amount of money. Still is a lot of money, but would have been a tremendous amount of money. So the decision was made. However, like a lot of things, as you look back on it over the years, it has been kind of a disruptive problem because you can't see so much of what happens in the gym. So this seems to be the right time. We were in a situation when we were preparing for the performing arts centers and beginning to put the bond millage together, the extension of the 2 mills. Then I happened to ask our architect, Dave French, who was with me there looking where we would put the Performing Arts Center, if he would just take a look at the gym. And when he came in, I said, is it feasible or possible to take these out? And he said, yes, it really is. And he said, it might not be as expensive as you might think. He said, let me do a little work on it, and he did. And as a result of that, the Board of Education looked at it and decided that they would actually put that in as a part of the extension of the 2 mills. So we were able to do it without raising taxes. We just extended that 2 mills out a little longer, along with the Performing Arts Centers and Garfield's Gym and Central. It just seemed like the right thing to do. We put it on the ballot, and the voters approved it. And now we're in the process of doing it so that by next fall, our kids will be in a totally different situation, and our 2 high school gyms will be very equal.
Well, now we know why the columns were there in the first place. But now a decision has to be made on how to take them away. And they are 2 supporting pillars. It's a decision that carries some weight. This fell on the shoulders of Barton Mallow, a $1.3 billion a year construction company that specializes in the school market. We asked project manager Bob Herbert on how they plan to come up with the best solution from all the possible ways of eliminating these center posts.
The voters asked for those columns to be removed, and the solutions that have been brought forward to do that job were very intrusive. There was a lot of work involved. We had to tunnel under the tunnels and put extra footings in, and they were going to basically beef up the other column structures that were in there. And it was a very intrusive job, tearing up the gym floor, time and money. It was going to last about 8 months, and it just didn't seem like the right way to do things. So my staff and I, we went for a walk and sat in the gym and said, you know, there's got to be a better way of doing this job. And we went back to the planning team, the architect and the owner, and said, you know, is there any way that we could support this from above? And quite honestly, we weren't sure how to do that. We just said, is it possible to build a truss over top of the gym, support it from above, cut the truss, cut the columns out? If you could do that, we wouldn't have a lot of work inside, cut down the time span of construction, less impact to the district. And we found that the engineer liked the idea. It's done in a industrial basis quite often in factories and such. They do that so that they keep floor space.
And floor space is definitely needed. So it's a matter of truss. A proposed 160-foot steel truss. And since you can't go to your local hardware store and get one, well, somebody's going to have to build one. The low bidder turned out to be a local company, Ferguson Steel. Ferguson Steel began fabricating and erecting steel in 1916 under the direction of owner James G. Ferguson, who was later joined by his son, James Bruce. They moved their operation to its current location in 1944, where the reins have since been passed to grandson Bill White. Mr. White explained how he approaches the design and construction of a project.
Well, when we receive prints, generally we'll get the prints from a general contractor or from an architect engineering firm. And what we do from there is we look at the drawings, and basically there will be structural drawings in there which will determine the size and location of the steel. From that, what we do is, it's called a material takeoff. That's the first thing we do. We go through the drawings and we determine where the columns are, where the beams are, what size the material is, any other miscellaneous steel items, and we do what we call a steel takeoff. The steel is sold by the pound. We buy it by the pound, just like you'd buy a pound of ground meat. So what we do is we try to get the material as accurate as we can on a weight basis. From there, we also have to estimate our engineering and detailing time, because from the structural and architectural drawings, we have to develop our own steel drawings. So we go through and determine how many hours it's going to take for our detailers to draw the steel.
Ferguson detailers must take what is described as the stick figures of an idea and flesh out the exact dimensions so that a structure can be built.
Well, here at Ferguson, what we do is Bill White's our owner and president. He came in and said that we had gotten the Port Huron High School truss project. We had talked about this previously and knew that we had a large truss that spanned across the entire gymnasium, and its purpose was to remove two interior columns that were always blocking the audience's view. Along with that, we had the complication of how to hold up the building and remove the columns at the same time. That was a design phase that had to be discussed in there too. So we go ahead and start drawing. We use a computer to draw and do all of that in AutoCAD and in a program called SteelCAD. Now in this case, we did most of it what we would call is line-by-line drawing, which is using AutoCAD to actually draw per exact dimensions, draw the entire thing 160 feet long and by 12 foot and whatever dimensions that we needed, and then allowing us to come up with a cut list so that the shop in the end would know exactly what size plate to make, what length angle to cut, what size that this needs to be, and also at the same time showing them where to put everything. Dimensionally, we have to show all of this information so that when it gets to be built, the shop would have all that information needed so that they don't have to come into us every minute and say, hey, how far is it to this piece and to this piece, and how long do you want it? That's all of the stuff that we would do in the detailing office.
With the plans completed, the workers, known as the layout crew, now have all the dimensions needed, even how much weld is required. Layout manager Tony Kennard.
Everything on here has to be at least a 5/16 weld, which took 3 passes using a 532 rod. One man working on this could spend hours on each one of these joints, there's several feet of weld in each joint, and 3 times that, it would be an awful lot of time spent welding. and a lot of welding rod was used up to get this completely welded. And a picture that most people could understand would be similar to a bead of caulk, and that would be 5/16 of an inch high and 5/16 of an inch wide, and then it would have a crown in it that should measure 5/16 also. Now this would be an example of the 3-pass 5/16 weld running on this diagonal angle, and it's also here on the bottom of this T.
And time is of the essence. Even though this is a huge project, this is just one of the many projects that Ferguson gets in a year, and it must be done within 3 months. The work gloves go on. Now all that's left to do is lift these pieces up and put them into place. And to lift that much weight, you're going to need something bigger than your average crane. In fact, the crane would have to have a reach of 400 feet. That crane is Big Grizz. Big Grizz is a 360-ton all-terrain unit which was built by Liebherr, one of the world's leading manufacturers of construction machinery. Hence the name Big Grizz Liebherr. This $2 million crane weighs 170,000 pounds when it's traveling, but when the weights are put on, it totals up to 454,000 pounds. Poundage that is required for the crane to counterbalance the weight of the 3 pieces.
The reason that we had to separate the truss instead of having it one large piece, 140 foot long, mainly was transportation. We have something here that we cannot get down the road if it's that big. This truss is 12 foot wide at the base, 12 foot high, and then it goes all the way around. It's a box truss. It is laced with angles and member pieces that are so huge that it's just, there's no way we can get this much onto a trailer, let alone transport it down the road. So what we had to do is we had to separate it into 3 main sections. And we chose those sections based on some criteria for splicing and the ability to take some loads. We then had to design a splicing connection that would be boltable, that would allow the truss to not sag once this thing is built together. It actually will become one piece when it's all put together.
Ferguson came up with a plan whereby they would divide the truss in 3 pieces and erect it that way. The longest piece, I believe they range from 30 to 60 feet. The longest piece is 60 feet long. And the pieces, I think the pieces total weigh 79 tons, what they call a box truss. And this truss will support the roof at the column line, and the columns can then be taken out. We have large column pads that are on the west end of the truss. There'll be columns in the existing corridor. So we basically dug a hole in the corridor, placed footings down below the locker room grade that's supported on the west end. On the east end, there's 4 column pads which acts as an X-brace, and those columns, very large. I think the column pad was 20-some feet by 20-some feet. 4 very large columns that stick up out of the ground. And then the steel column structure will be bolted to that. And for the most part, we were able to stay out of the building, which was no impact to the kids, no impact to the the existing structure. The truss will be visible while we're erecting it, but quite honestly, afterwards, it's going to have a screen wall around it. It'll look like a mechanical penthouse that's on most buildings. So at the end of the day, it'll be pleasing to the eye. It'll match the building, and it'll support the roof.
Once the holes were cut in the gym roof to support the structure, the project got underway. With the panels in place, it gives the structure a finished look, but it doesn't compare to the view inside. They say a picture's worth 1,000 words. Well, the voters have just given themselves a whole new chapter to add to their view.
We've had several opportunities in the past to move these beams, but nothing ever happened. This time it's happening, and everybody's talking about it because it doesn't seem to be that big of a problem until you sit behind that beam and it's your son or daughter that's you can't see, and it's finally going to happen.